Okay, here we go. Week 4 geometry. We're going to do quizzes 3, 4, and then you can do the unit test, which is last week and this week's material put together. Okay, so quizzes 3 and 4. That's what I'll do right now. And so last week we talked about the Pythagorean Theorem and a little bit, right? But now we're going to do applications and then go into volume. Okay. The perimeter of the trapezoid. So a perimeter means the length all the way around the figure, but you'll notice that this trapezoid has some slanted sides. So what is the length of that side there? Well, you can't just count the boxes willy-nilly and say it's like 4 or whatever. You have to be precise. So what we do is we draw in a right triangle. And we use the Pythagorean Theorem, our tool, to figure it out. So now I know the height of this right triangle is 3. The base is 4. So this is a Pythagorean triple, a 3, 4, 5 triangle, right? We know a squared plus b squared equals c squared. I can substitute 3 and 4 in. That's 9, that's 16. They add up to 25. Square root. And you get 5. Just in case you didn't know. But now going forward, just want everybody to know, if my writing thing works, 3, 4, and 5 is called the Pythagorean triple. So if the base and height are 3 and 4, the hypotenuse is 5. Another one you'll see all the time is 5, 12, 13. Pythagorean triples. So just to know. And look, on the other side, we have 3 again, and we have 4 again. So that's 5. And then there's this 1 in the middle, and there's 1 on top. And now we can add all these sides together. 1 plus 1. I'm sure you know that. Plus 5 plus 5. Plus the 4 plus the 4. All those things added together will give me my perimeter. So 1 plus 1 is 2, plus 10 is 12, plus 8 is 20. Okay. Elise walks diagonally from one corner of a square plaza to another. Each side of the plaza is 50 meters. So I definitely want to draw a picture, okay? Because one thing about geometry is we can always draw a picture. So we know she's in a square plaza. She's walking diagonally, which means like that. That's what she's doing. Okay, and then we also know each side of the plaza is 50 meters. So we could just put in our 50 there. And okay, so what is the diagonal distance? Well, now you can see we have a right triangle right here, right? And our base and height are 50. So we're gonna, that's our C, you know. So 50 and 50 is like 2,500, 2,500 plus 2,500 equals C squared. So that's 5,000 equals C squared. Take the square root, take the square root. Round that 70.71. To the nearest tenth, so 70.7. There we go. Okay, so I'm not going to do this whole one, but just to tell you that this is a diagonal line. So again, we draw a right triangle, identify the base and the height, use the Pythagorean theorem, and you will get it. Well, okay, so this one, we could do this one. So we need the area, right? So we need our height. We don't know our height. Just make sure you know that, let's call this B. Just make sure you know that the missing component is on the left side this time of the Pythagorean theorem. It's not the hypotenuse, right? So we are going to end up subtracting when we solve this guy, 6.25. See, now I need to subtract 2.25 from both sides. And then we get 4. And then that would be squared is 4, so B equals 2. But don't put 2 in there because we want to find the area. And the area of a triangle is 1/2 base times height. So now we know it's 1/2, 1.5 times 2. That would be 1.5. Of course, I do that. Oh my gosh. All right. So that should be good. Now, look, this diagonal is going from the back top corner to the front, right? So technically, we need to write in our base and our height. So it's not that hard because we can see the cube, it's a cube. Yeah, 60 all around. So that means the height here is going to be 60. And then across there. Well, now we don't know across, or you can figure that out. Okay, so we got to do is we got to figure out the across for the base. We know the height 60, and then we'll be able. So this is a double Pythagorean theorem one. So you see this. Let's start out with the green triangle. Let's make a green triangle. Okay, so did everyone see the green triangle? The green triangle has 2 60s, and then the so that 60 squared, 3,600, which is 7,200, and then take the square root of that, 84.85. Okay, and then the one that we want is 60 squared plus 84.85 squared equals d squared. You see, I just found the base of this triangle right here, and that's 84.85. And then we know the height is 60, and we want to find that distance. I already know that 84.85 squared is 7,200. 60 squared is 3,600. Add them together, and we've got our plan. 7,200, 10,800. And then you take the square root, and you get 103.92, which rounds to 103.9. Okay, quiz, and we only got 2 quizzes to do. No problem. Quiz 4. So, all right, so now let's talk about volume. Volume, the number of little unit cubes you could put inside of a figure. But, and we want to memorize our volume formulas. Some people don't think that's important, right? If you don't know it, then how are you going to use it? So the volume of a cylinder, let's do our volume formulas. Volume of a cylinder, start with the volume of a prism is base times height times. So it's the base area times the height, right? So base times height, or length times width times height. But then when we have in general, the volume is the base area times the height. So whether you have a rectangle and then you're multiplying it by the height, or maybe we have a cylinder, right? So what's the base of a cylinder? It's a circle. And what's the area formula for a circle? Pi r squared, right? So we're just going to multiply that by h. And if we have pyramids, how about a pyramid? Guess what? It's still the base area times the height, but we put a 1/3 in front. And a cone is the same thing. It's still, the base is still a circle in a cone, right? If you think about it. And then here's a pyramid. There you go. So the cone is very similar to a cylinder, but there's a 1/3 in front. It works out that with pyramids and cones, the volume is exactly 1/3 of the related cylinder or prism. Amazing and beautiful, all at the same time. And the volume of a sphere, 4/3 pi r cubed. Isn't that beautiful? Still got that pi and that r, but this time it's cubed. So we're looking at a cylinder. We know the radius of the base. We know the height of the cylinder. And we know the formula is pi r squared h. So we're just going to substitute pi 6 squared times 4. That's all you got to do. It says either enter an exact answer in terms of pi, which is what we'll do, or use 3.14 for pi. No, not interested in that. So 36 times 4 is 144. And so the exact answer would be 144 pi. And the volume of our sphere, we know that is 4/3 pi r cubed. And so we have our r, and that's all we need. 4/3 pi 5 cubed. So I'm gonna, 5 cubed is 125. And so let's just multiply that by 4/3. So it's 125 times 4. Why am I using my calculator so much? Sorry, guys. So it's 500 over 3 pi. And so we can just put that 500 over 3 pi. Okay, so you can do that one. You don't need my help for that one. And well, this is the easy one. Volumes of cylinders. And all right, and the Pythagorean theorem in 3D, but you can do it. It's going to be great. And post in the organizer.